Titebond might be best known for their wood glues, but professionals also rely on their sealants to tackle the toughest parts of the home. One of the standouts is Titebond UA 920 sealant. It's a premium hybrid sealant made to move with siding, windows, doors, and trim, whether you're working inside or out. It stays flexible over time and keeps joints sealed as the house shifts and settles. If you want to learn more about UA 920 or check out the rest of Titebond's caulks and sealants, head over to titebond.com. Upgrade your home's exterior with Exceed Siding by Versatex. Engineered for unmatched durability and a sleek, modern aesthetic, Exceed provides a high-performance, weather-resistant shield that outlasts traditional materials. The ultimate low-maintenance choice, Exceed's advanced polymer construction resists rotting, cracking, peeling paint, and fading. Lightweight 16-foot boards, nail hem brackets for tight joints, and the VZD drop lock system for solid straight lines make installation faster and easier. Plus, with a built-in color cap, there's no need for routine painting. For a premium finish that stands the test of time, choose Exceed Siding by Versatex. This comes from Benoît. Benoît writes, "Hey Patrick and FHB podcasters, I'm writing to you from our home on Wolfe Island, nestled on the St. Lawrence River at the mouth of Lake Ontario. From the north side of the island, you can see Kingston, Ontario, Canada. From the south side, you're looking at New York State. My wife and I purchased this place and moved here in April. It's a stunning waterfront property with a 1-acre lot, bungalow, and a large bunkie. We started with the house, which had to be taken down to the rough sawn framing. It turns out every stick of this home was built from reclaimed lumber." We had a conversation about building on an island recently on the podcast, and I'm guessing that's what's going on here. It was a big job revamping this house, but after 7 months of living in a 20-foot trailer with our 1.5 and 3-year-old sons, we moved in on December 10th. The house is comfortable and cozy now with barely anything else to do on it. Just kidding, there's still lots to do. Second bathroom, shower tile, doors, trim work, closet shelving, siding, the list goes on. However, as the bank account continues to drop, we are thinking ahead to having some rental income from our bunkie by the water. This building is what we're writing to you about. It's a relatively new 2008 stick frame construction with board and batten siding. It's 1.5 stories with a nice big dormer on the water side, which leads me to my main question. The exterior second-story knee walls are really starting to lean out because of the natural thrust/weight on the roof and the lack of collar ties. As it stands now, there are short 2x4 collar ties down about 1 foot from the bottom of the ridge piece, leaving us about 7.5 feet of ceiling height. I put the level on there, and as expected, the walls are 3/4 out and about 3 feet. We'd like to finish the bunkie and have a large open bedroom upstairs. The view is gorgeous. Is there anything I can do here to avoid the classic roof sag that happens in so many old houses? It seems like such a careless design flaw to me. One idea I've had to prevent this issue from getting worse is to add a beam across the whole length of the ridge to replace the need for collar ties. This would mean adding a post in the middle upstairs and directly beneath on the main floor. Would this provide enough support, and will I ever get the walls back to plumb by pulling in at the top of the knee walls and jacking the ridge up? My other question for this building is about the floor. It's a poured slab with no moisture control layer. It's wet in there half the year. Any suggestions on how to finish it? There is drainage tile and coarse gravel around the exterior of the building. Thanks for your time, FHB. I absolutely love the podcast and listen whenever possible, often on the 10-hour drive to and from my hometown near Desbarats, Ontario. And forgive me for mispronouncing that, Benoît. My wife has started to really enjoy the podcast as well, but it often lulls her to sleep in the passenger seat. The kids and I really enjoy reading the magazine on the couch too. I look forward to your reply. Proud All Access member. Benoît, thanks very much for the support of the brand, and the photo of you and your 2 kids was adorable. Thanks very much for that. I shared it with the staff. We love getting stuff like that. Okay, very quickly, I'm going to describe what the problem is here as best I can, and then we're going to go to you guys, and you can weigh in here. So this barn, bunkie, if you will, is platformed framed with rafters, not trusses. So rafters rely on the rigidity of the top of the walls to resist thrust, specifically to prevent them from pushing outward. You need some kind of structural element that prevents this spreading In really simple terms, you're talking about you need the bottom leg of a triangle, right? Without the bottom leg, the triangle has no strength. Ceiling joists can perform this function. Rafter ties and collar ties, we'll talk a little bit more about the difference in a little bit. And on a 1.5 story structure, this is a challenge because the rafters bear on these short sections of wall without ceiling joists, because otherwise the ceiling would be 3 foot tall, right? And there's nothing to hold these little walls in at the top. So how is this solved in new builds? A primary way to do this is with balloon framed walls. That is, you have the walls go from the first floor bottom plate all the way to the 1.5 story top plate, and then you use some kind of ribbon board or ledger to support the floor system. You can do this with trusses, because trusses can be engineered to resist this spreading in a way that rafters can't. Grant, what do you think is the best way for Benoît to fix his existing building, which I think we all agree, we were talking ahead of the show, was framed badly in its inception? How do you fix this?
Yeah, I think at this point, the only way he's going to be able to fix it is exactly what he said, is he's going to have to jack up the ridge and put a ridge beam underneath it. So kind of just some brief, we were talking about roof framing before the show, but just so everybody's on the same page. So, as Patrick said, rafters rely kind of on the triangle. So they need a rafter tie of some sort at the bottom of the triangle to hold the point loads coming from snow load, things like that are on the roof, from kind of splaying out the two legs of the rafters. So that can be done either through a rafter tie itself, which is typically the ceiling joists. As Patrick said, you could balloon frame, and there's certain things you can do there, but rafter ties are typically in the bottom third of the rafters, where he references collar ties. So a lot of people think those are for keeping the roof from sagging, but they're actually not. A collar tie is high up, typically the upper third, and that's actually there for high wind to keep the ridge from separating apart. So collar ties themselves actually don't do anything, and that's a very common misconception. They don't do anything to prevent spreading. So in something that has a rafter tie, you can get away with what's called a ridge board. So it's non-bearing. It's just there basically to give you the two opposing rafters something to rest on. But in the case where you don't have a rafter tie on the bottom, you have to have a bearing ridge beam. So a beam that's capable of supporting half the load of the roof or whatever it is. You can calculate tributary load, but essentially it's half the load of the roof has to be supported at the ridge. So basically it takes those rafters and makes them individual structural elements that bear at 2 points, the top and the bottom. That way they don't splay apart at the bottom.
And, you could get help at a lumber yard or with an engineer with sizing this beam. And if you're going to put a bearing point in the middle, you might not want it exactly in the middle. You could move that to a degree to make the spaces more functional instead of having it right smack in the middle of the floor.
Yeah, do your design layout of what you're going to turn that upstairs space in, and then work with an engineered materials designer to figure out where you can put that splice in the beam so you bury your post inside of a wall. I'm sure you're going to have some walls splitting up the second floor of that space. Should be able to lay that out easily.
Yeah, and these are typically very large LVLs or multi-ply LVLs.
Yeah.
They can be steel too. A lot of times you can put steel, but that kind of gets weird because then you're lower, because there's really no way to frame a rafter into a rafter on a steel beam. That's why a lot of people use LVLs, but something there, a beam. And to his question of if he jacks up that ridge, he's probably gonna have to put come-alongs or something between the two top plates.
Yeah, and that has to be done at the same time, right?
Exactly. You had to do it all. You had to do it all at once. The hardest part, I think, for him is going to be finding something solid to push against when he's trying to lift up the ridge. Because if he's that high, he's almost going to have to put shoring or a very long post of some sort. Because he's going to have to push that off the foundation. If he pushes that down against the floor, it's going to deflect. It's not going to go well for him.
And you might consider, your footings that are going to be the bearing for your ultimate structural ridge beam as temporary footings for the jacking process too. So once you locate those, then you can make them oversized, right? You're going to have to make them bigger than you would ordinarily because you're going to need room for both your jacking and your permanent posts.
And that's a great point, Patrick. So wherever if you have a bearing beam, it has to, those loads have to carry some way through a solid load path to the foundation. So, they are going to have to carry through a post to another post or however you're going to do that. And then they need to be on a footing. So a lot of people, will just put them in the middle of a slab. They can't do that. They have to be on a footing because they support, when you actually do the calculation on that, especially in, I'm very familiar with this place. I was saying before the show, like, this is my favorite place in the world to go fishing. My family used to own a house probably as the crow flies, maybe 3 miles away from where he is. But that's, I think it's either 6A or 7A. You get a lot of snow up there. So when you actually calculate what, 80 PSF on the roof is, it's a lot of load coming down through those posts at the end of the beam.
So we have to talk about non-conventional ways to fix this, right? So, wood framing is fantastic with compressive loads. It is not so good with tension, right? Steel is fantastic in tension, not so good in compression. So if you could figure out a way to link these short dinky walls to the bigger walls below going through the floor system with some kind of steel on the inside, you might be able to resist further spreading. Andy Engel did something on outbuilding a garage he built with a living space above. In order to make it more useful as a book, Carpentry Complete was the title, published by Taunton. He platform framed the story in a half to make it, more typical of conventional construction, right? Most people don't frame structures with balloon frame walls anymore. So he used these pony walls and then tied them back to the ceiling joist, the second floor joists, with steel straps through the subfloor, and created a tension on these angled pieces of steel to resist that spreading. And then interior of that, he framed like what amounts to a second pony wall that is a partition to hide these steel straps that come in interior to the space. So, would you get an engineer to sign off on that? I don't know. The School of Yankee Engineering clearly was good enough for Andy, and I've been to the building. It didn't seem to move at all.
I've stayed in that. Stayed in that building before.
Did you know it was framed that way? I peeked behind those walls one day and I was like, Andy, what the heck is going on here?
I did not. I had no idea it was framed like that.
Would you have stayed there if you did?
Sure. Yeah. Andy built it. If he built it and said it was fine, I wouldn't think twice.
Well, if you think about it, that's kind of like, in a way, it's sort of like what a truss manufacturer can do. They tie the cords together with structural connections to resist those.
Using tension really, often.
Exactly. Yeah. It's usually not much different. I mean, theirs is usually a little more engineered, but it foreseeably, it could work. It just have to be really sure that bracket can transfer that load in tension.
I corresponded a little bit with Benoît and suggested he, ask an engineer. They might have a cheap solution for this that involves something that doesn't involve lifting a structural ridge to the top of this roof, which is...
When you reach out to that engineer, really give them the parameters and the constraints of the project. Otherwise, they might get a little overly creative, or they might just say, well, you need like a long steel beam. And then you're like, but it's on an island. How do I get it out there? How do I get the thing to lift up the steel beam to the island?
Right.
Give me something I can put in a rowboat.
So, maybe it explains why they didn't balloon frame this in the first place.
Well, I wonder where this guy got on the boat.
Right.
I wonder where this guy got all of these 3-foot chunks from. Like, did somebody get 12-footers and then they wanted a 9-foot ceiling somewhere? So he found a construction site that had a stack of 3-foot studs on it.
Yeah, the good thing about Wolfe Island is it's served by ferry, as opposed to a lot of the other areas of the Thousand Islands are not. Their private islands are not served by ferry. So, you're probably a little more likely to get a crane and a big piece of steel to Wolfe Island as opposed to like Carlton Island, which is right next door. But but there's people out there that are pretty good at this. So I bet you somebody can figure it out.
Aren't you going to stop by and help Benoît with this, Grant? You're practically there all the time.
Yeah, you need to.
You guys can handle this.
You need to email us back and let me know where on Wolfe Island you are, and I'll make a trip if I'm up there. I'll be up there a few times this summer for sure. So, let me know. I fish all the time. Like, a fisherman never reveals his spots, but there's a couple shoals in the vicinity of Wolfe Island that I've had very good luck fishing for walleye on. So,
Benoît, you're going to
Brian Pontilillo at the magazine and propose Grant's next vacation writing trip.
That's a great idea. Email Brian and all of us, and I'm sure he'll jump right on that.
Grant, they rent those materials handlers at Home Depot to lift this beam, and I'm sure you can push that on the ferry. You guys are going to need that.
Yeah. Yeah, we'll have to cut a hole in the floor to jack it up that high. So,
I hadn't thought about that. Yeah, that's a problem.
Yeah. It'll be good. We'll make it work. Somehow I'll make it work.
You just have to frame some partition walls, temporary walls underneath where you're going to put it up on the second floor, right?
Yeah.
We didn't tackle his wet floor problem, though. You got any ideas on that, Patrick?
Oh, man, that's hard. So Zypax, I think, is some kind of, Grant, you're nodding. What is that stuff?
Yeah, I believe there is a post pour additive. Typically Zypex is added during, I think it's Zypex is what it's called. It's added during construction as a moisture barrier. It's added like while the concrete is still plastic, like as it's mixed. But there's definitely things you could put on that slab. I would probably lean towards, I feel like I've been saying this a lot lately for some reason, but I lean towards grind it, get a little, my person, I'd grind it and get a little exposed aggregate look going. And then I would, you can get a sealer that's a vapor barrier and just seal that puppy. And that's how I would do it if it was me.
And it's finished flooring and it looks amazing. Yes.
And it's easy to maintain too. And, every couple of years you might have to touch that up, but that's, you can definitely get a clear sealer. It's going to look good and it's going to hold that moisture down in the slab rather than inside. The other thing is just run a dehumidifier in those areas, but where he's at, it doesn't get very humid. You're talking the humidest part of yours maybe gets to 80 degrees.
When all that snow melts out, dude, it's going to be sopping wet in the springtime for sure.
Yeah, he's going to definitely have like ground moisture from that way, but he doesn't. I think he'll be okay. I would just run a dehumidifier if he has to, and I'd grind the slab and put a vapor barrier on top of it, a liquid material, and call it a day.
I love that idea.
I love the exposed aggregate look, and it's cheap too. Like it's not.
Benoît, if you don't want to do that, write us back and tell us, come up with something else.
Think about it this way: you only had to bring a grinder on the ferry over down instead.
You can rent those at Home Depot too. Maybe you can get like a discount for a whole week on both those machines.
Yeah. See what they do if they deliver them out there.